Today, we're going to go behind the scenes and take a look inside the wild, incredibly complex world of high-tech apparel manufacturing. You'll see it's a journey from total, absolute chaos to precise, intelligent control.
You know, that technical jacket you own, it's an incredible piece of engineering. But have you ever really stopped to think about how a factory actually pulls it off? I mean, with so many steps, so many tiny details, how does the whole thing not just fall apart?
Well, the truth is, for a very long time, it basically has been a constant, daily fight against chaos. Just a storm of small, cascading problems that can bring the entire production line to a grinding halt.
In fact, you can break it down into over 30 distinct headaches, all these little pain points that pop up in a traditional factory. And these aren't just minor annoyances, they're symptoms of a system that's fundamentally broken.
Just think about the big picture problems this chaos causes. Deadlines get blown because of delays nobody saw coming. The quality of the final product, it's all over the map. And a truly shocking amount of really expensive, high-tech fabric just gets thrown out as scrap.
And if you zoom in on the factory floor, the problems are even more immediate. Machines are constantly breaking down. Workers are trying to follow confusing, outdated paper instructions. And all of this creates these massive bottlenecks where work just piles up, literally going nowhere fast.
And here's the key takeaway. You can't just slap a bandage on each of these 30 problems one by one. It's not going to work. The entire system, from the ground up, needs a complete and total redesign. So let's see how that transformation actually begins.
Okay, so step one in this whole transformation is to create a digital blueprint. The goal here is simple but so powerful, to create one single, undisputed source of truth for everything and for everyone in the entire factory.
And that blueprint is a system called PLM, which stands for Product Lifecycle Management. Think of it as the factory's digital master plan. It holds every last piece of data, the bill of materials, or BOM, which lists every single component, and the bill of process, or BOP, which details every single step to put it all together. It is the ultimate authority. This is a game changer. I mean, before, you had data scattered everywhere, in different systems. Nobody knew which design version was the right one. But with PLM, everybody, and I mean everybody, is working from the same playbook. And here's the crucial part. If you want to make a change, you have to file a formal engineering change order, or ECO. That makes sure nothing ever gets out of sync.
Now, this digital master plan doesn't just live on a server somewhere. It goes right down to the factory floor. So those old coffee-stained paper manuals, they're gone, replaced by ESOPs, these electronic guides at every single workstation, showing clear videos and diagrams that are always 100% up to date.
All right, so once you have that stable digital foundation locked in, you can start to revolutionize the physical production line itself. This is where you turn those frustrating bottlenecks into a super smooth, efficient flow. The key idea here is something called conwhip. Now, instead of the old way, just pushing as much material as you can onto the line and hoping for the best, conwhip acts more like a traffic controller. It limits how much work is in progress at any one time, and it only pulls new work in when there's actually room for it. This simple change prevents traffic jams and makes everything move way faster. And this smart flow, it's like a perfectly synchronized dance. It happens in 3 stages. First, an AI figures out the absolute best schedule, considering everything from worker skills to machine availability. Then, when a station is ready for more parts, it sends out a digital signal called an e-Kanban. And finally, these little robots, autonomous mobile robots, or AMRs, zip over and deliver exactly what's needed right when it's needed. No more waiting, no more searching for parts.
This kind of control leads to some incredible efficiency gains. By using smart techniques to standardize tools and processes, the factory can slash the time it takes to change a line over to a new product by up to 40%. I mean, that is a huge leap in how agile they can be.
And the savings aren't just in time, they're in the materials too. Remember all that expensive wasted fabric? By using smart software that optimizes the cutting patterns, they can reduce that waste by as much as 15%. That is a lot of money saved.
So we've got a stable plan, and we have an efficient flow. The next piece of this puzzle is a total rethink of quality control. It's about shifting from just catching mistakes at the end to preventing them from ever even happening in the first place.
Okay, take a really critical step, like sealing the seams to make a jacket waterproof. You absolutely cannot afford a mistake there. So they build sensors right into the machines that monitor every single variable in real time. That data then feeds into a system that can spot a problem developing before it actually results in a bad part. It's like seeing into the future.
Now, when a defect does slip through, the analysis is incredibly precise. It's a 3-layer coding system. It tells you exactly what the defect is, say a seam leak, where it is on the left shoulder, and most importantly, why it happened. The machine pressure was wrong. This lets them find the true root cause and fix the process so it never, ever happens again.
And this whole philosophy goes all the way to the final inspection. You know, the old way relied on a person's judgment, which, let's be honest, can be inconsistent. The new way uses AI and 3D scanners to create a totally objective, repeatable standard. It catches tiny flaws the human eye would almost certainly miss.
So the last piece of this puzzle is the machines themselves. The goal here is to stop treating maintenance like firefighting, rushing in after something's already broken, and instead make it a proactive, intelligent strategy.
This is called predictive maintenance, or PDM, and it's brilliant. By using all that live sensor data, the system can actually predict when a machine part is likely to fail before it breaks. So technicians get an alert to perform service during a planned break, completely eliminating those chaotic, costly, unexpected shutdowns.
So, after all this work, what's the payoff? Well, the results are seriously impressive, and they're measurable. We're talking a 40% reduction in the time it takes to change over a line, a 15% cut in material waste, and even a 15% drop in energy use. This isn't just theory. This is real, tangible value being created.
And maybe the smartest part of this entire system is this: no improvement is ever forgotten. Every single successful change, a new tool, a better process, whatever, it gets documented in what they call a standard replication package. This basically becomes a blueprint that lets them copy and paste that success across other lines or even into entirely new factories. It really makes you think, doesn't it? All of this incredible intelligence and fine-tuned control is being used to make the jackets we wear. So if this is what's happening inside the factory today, what comes next? What kind of amazing things will these hyper-intelligent factories be building for us tomorrow?